Hey guys, real quick before we get into the video, we've received amazing feedback from the last compilation video. If there's a specific topic that we covered in older videos that y'all want to have compiled together, please let us know down in the comments. And thank you so much for 30,000 subscribers. Y'all are the best. As always, thank you for watching.
Is OPC UA the future of IoT? Answers to your questions, take 0. In this video, so you'll remember from last month, we posted a video on is OPC the future of IoT? You can watch that video either here or here or here or here. That video got a lot of responses. Okay, so for example, some of the responses, some guys from PTC responded, hey, in your video, you had ignition in the middle. We use ThingWorks in the middle. I'm going to respond to that. There were people who asked a question about OPC UA PubSub Part 14 of the standard and why is it you didn't bring that up? And I'm going to bring that up. We're going to talk about that. Actually, it'll probably be the first question we answer. But why did I not use PubSub as an example of is OPC UA the future of IoT? A couple of what were example of some of the other questions that we got, Zach?
Someone brought up another example of the bank analogy.
Yeah, someone used the bank analogy where I was saying with IIoT, someone had made the comment, hey, playing devil's advocate, when you open up a new bank account, there's actually a person who adds that and ties it in. It's not entirely true. It's actually not true at all. When they create the account, they tie that to you, they tie that to the person, and it just shows up in the UI. It's self-aware. It just shows up in the UI. There isn't an engineer who's mapping it to the UI so that it shows up on my phone, which was exactly what my point was. Go ahead, Zach, and any other questions?
There was a couple other suggestions, a couple questions on Intellic as a business, and also other video suggestions.
So in this video here, this will be a series of answers, I think, just so that the video doesn't run too long. I'm going to go ahead and just answer the questions in video form. We'll probably tie it as a comment in the video in LinkedIn. So to get started, let's go with the very first question.
Question number 1 is from Omar Tariq.
Omar Tariq.
The latest OPC UA standard supports PubSub.
Okay, great. So the question here was, Walker, why didn't you reference OPC UA PubSub in the video as relation to the future is OPC UA part of the future of IoT? Okay, here's why. PubSub is to OPC UA as Sparkplug B is to MQTT. Okay? So OPC UA is a standard for organizing data. Okay? And so with the PubSub is really just the communications mechanism that they're using. In most cases, when you're going to be using OPC UA PubSub, that is, you're going to be using the OPC Part 14 of the new standard, and you can read the press release on the opcfoundation.org. It's basically excrement. It's useless to read it. It's another example of why I don't understand why people in our business try to write things to make themselves sound smart. The average engineer is not going to understand what you're saying in that press release, by the way, from the OPC Foundation. I understand it just because this is my life. This is literally what I do. So Part 14 of the OPC UA standard is PubSub. It's basically a standard for how do you retrieve data that is formatted using the OPC UA structure and the OPC UA security methodology. So OPC UA standard has language for how you should be securing the data end to end. Okay. Part 14 of the standard is all about how do you retrieve OPC UA formatted data using a publish and subscribe architecture. So that is, I want to subscribe to a specific set of topics and only be notified when they update. As opposed to right now, without using PubSub, I have to poll and wait for a response. I have to check for the updates. Have you updated yet? Have you updated yet? Have you updated yet? PubSub is, I just let you know what I want to be notified as to what's been updated, and when it updates, you push me the update. Okay, which it obviously uses a lot less bandwidth. It is much more efficient, and I can receive messages from many, many more nodes in the field because I'm only getting them intermittently as things change. Okay, so the answer to the question is PubSub is not a fundamental change to OPC UA. Okay, well, one of the problems with OPC UA is that it's not lightweight. Okay. So in order for us to say that we define IoT protocols, we have 3 requirements that they all have to have. Number 1, they need to be open. What that means is they got to play nicely with everything, and they have to be openly available to everyone. The OPC Foundation likes to say that OPC UA, they actually call it an open architecture. It is not. Open is available to everyone. And the OPC UA standards are not available to everyone. They're only available to the people who join the OPC Foundation. You have to join the foundation to get the standard. That is not open, okay? So that's pay to play. It is literally the opposite of open. They are not the same thing. OPC UA defines open as we don't discriminate. Once you've paid to play, we don't discriminate what you can talk to, which is not entirely true. I mean, you can only talk to OPC UA and DA compliant clients, but the reality is it's not open, okay? It's not completely open. It's not closed the way Rockwell does their work, the way Rockwell does things. Number two, it's not lightweight. So what does that mean? When I set up a communications channel between a server and a node, there's two different types of communications. There's the communications where I initialize that connection. So that is, hey, I am server so-and-so, and you can trust me, this is my certificate, and hey, let's set up an encrypted connection. There is a header and a payload associated with that connection. There is also a header and a payload that is associated with the response from the client. And then there's generally a stateful connection where they check in with one another to make sure they're still talking. So you have that part of the actual connection. Then what you have is the packaging and retrieval of all the data. When you receive an OPC UA message, it is a huge message. If you put Wireshark on your machine and go ahead and do a demand pull to one device that has, say, 10 tags configured inside of Kepware, and you look at the sheer size of the data that's transmitted over the wire, that is not lightweight, especially when you compare it to an MQTT header and payload, which most of the time is like this size relative to the OPC UA size. In fact, it's 1/25th. In average, it's 1/20. MQTT payload is in general 1/25th the size of an OPC UA payload. Okay. Now, number three, it's not report by exception. Now, PubSub is report by exception. Okay. So the OPC UA PubSub is one of the three requirements. It's not lightweight, it's not open, but it is report by exception. But here's the kicker. Most people don't know this, but OPC UA is just the standard for how you structure the data. It's not the communications protocol. You want to know how most people will be sending PubSub messages in OPCU format back and forth between clients and brokers? Over MQTT. That is literally, and it's in fact, it's OPC UA's recommendation. It's AMQP or MQTT data transfer protocols. Now, MQTT is messaging queue transport telemetry. It's a way of sending and receiving data. The Sparkplug B specification is a standard or a specification like the OPC UA specification for how you should package that data. Okay, but guess what? When you're using PubSub with OPC UA, 9 times out of 10 from that device, it's going to be over MQTT. So why not cut out the middleman and use the Sparkplug B specification, which was written specifically for MQTT.
We should do Sparkplug B versus OPC UA.
Right. I'm not an anti-OPC UA guy in any way, shape, or form. I think the OPC Foundation has done a phenomenal job writing the spec, and I think the people who are part of the foundation have done a phenomenal job. I'm only answering the question, is OPC UA the future of IIoT? And I don't know how any reasonable or objective architect can take 2 steps back, look at the landscape, and come to the conclusion that it is. That answer went a little bit long, but to summate, OPC UA PubSub is not open and it's not lightweight, although it's going to be more lightweight than pull response. But the payloads themselves, I mean, essentially what PubSub is going to do is package the OPC structure inside of an MQTT payload and then publish it with MQTT to an MQTT broker. To me, it's hard to argue the benefits of going that route when you could use the Sparkplug B specification, which gives you the same data in a much smaller payload, which uses a lot less bandwidth. What is OPC Take 0? All right, so this is not going to be a comprehensive analysis of OPC, okay? This video is being shot for 2 reasons and 2 reasons only. Number one, probably the number one question we get in the Industry 4.0 Discord server with our customers, with vendors is, hey Walker, Intellic Integration, 4.0 Solutions, you guys are really high on MQTT Sparkplug B, and you talk about MQTT Sparkplug B or MQTT5 all the time in your architectures. Where does OPC fit? Where does OPC UA fit? Why can't I use OPC UA here? And why can't I use it in this use case? Why should I use MQTT, right? The The answer generally is OPC UA is not an IIoT protocol or standard. Now, the people at the OPC Foundation would disagree with me. They're going to say that it is. The problem is the people at the OPC Foundation, the corporate members, the companies that make OPC tools, they don't do the projects we do, okay? So engineers who do the actual projects, the architects who design the actual projects, disagree with the OPC Foundation about whether or not it's an IoT protocol. So I'm gonna go ahead and explain why it's not an IoT protocol. I'm not here to bash the OPC Foundation. I'm not here to bash OPC UA. I'm actually here to celebrate it in many ways. But number one, I want to shoot this video after a couple of years to give you some updates, and I want to give the lay of the land on what OPC is, what's OPC UA, what is DA, what's the history of OPC, why are they in industry, etc., etc. Number two, I want to give a 10,000-foot view for the layperson on what OPC is. When they hear OPC UA, I want them to have a firm understanding. The viewer here, I want them to have a firm understanding of what OPC is, why does it exist, why do people use it, who manages it, what are the actual use cases. So that's what we're gonna do right now. So what is OPC? Very simple. OPC is OLE for process control. Object, link, and embedding for process control, okay? You're already familiar with OLE, okay? You may not know you're familiar with OLE. You may not know that, but you are. Back in the early 90s when you were using Windows applications, OLE was the mechanism that Microsoft offered in their operating systems for applications to talk to one another, to interoperate with one another within the Microsoft ecosystem. That's object, linked, and embedding. So that's how I could have a piece of software A view the files and the directories that were running in the operating system. I could link things that were native to the operating system to pieces of software that were running in the operating system. Use OLE to do those types of things. OPC is that mechanism, that methodology, but for process control, for industry, okay? So OPC is an extension of what Microsoft created in their operating systems in the late 70s, the 80s, and the 90s. Okay. OPC, the standards for OPC are managed and written by an organization called the OPC Foundation. Okay. The OPC Foundation is not a standalone group. They are really a consortium of individual people from various companies who have a vested interest in creating an interoperability standard so that their tools can talk to one another. Okay. The OPC Foundation, the president of the OPC Foundation is a guy named Stefan Hopp. He's actually from Beckhoff. Okay, so he's a Beckhoff guy, okay? Microsoft is a major player at the OPC Foundation. Rockwell Automation is a major player at the OPC Foundation. There are many members of Rockwell Automation. There are many people who work for Microsoft. There are many people who work for Beckhoff who are at the OPC Foundation, okay? So the OPC Foundation is the governing body for the OPC standards. Now, how do people use OPC? Like, what good is it to the layperson? Okay, so a common use case in a manufacturing facility, I will have PLCs operating on the plant floor. I may have a Beckhoff PLC, I may have a Rockwell Automation Allen Bradley PLC, I may have a Siemens PLC, all three of those things running on the same machine, okay, the same process. And what I want to do is I want to create a software layer that helps me to interact with that machine on the plant floor, okay? Beckhoff they have their own controllers, they have their own PCs, they have their own software to interact with that machine. Siemens has their own hardware and then WinCC that can talk natively to their own hardware to interact with the Siemens component. You've got Beckhoff can natively talk to the Beckhoff component. Allen Bradley, using the factory talk system, can natively talk to the Allen Bradley PLCs. Where OPC comes in is where we use standards and tools to make it so that I can have one thing talk to all three, okay? Now, there's a couple ways to do that. Number one, I could write a piece of software that can talk the native protocol Beckhoff uses, the native protocol that Allen Bradley uses, and the native protocol that Siemens uses. Those companies all use different protocols, by the way. I could do that, but I've got to manage three different protocols. And every time Beckhoff makes a change, I've got to update the way that I communicate with a Beckhoff. And every time Allen Bradley makes a change, I got to update the way that I communicate with Allen Bradley. So, and the same thing with Siemens. It becomes very difficult. OPC was really meant to make it so that I could make third-party tools to unlock value in my equipment in process control by talking through a common standard. Okay? Unfortunately, that isn't what happened over time. Okay. A very common use case is you would use a tool like Kepware by KepServer EX, made by Kepware, a company based in Maine, who's owned by PTC Technologies, the same people who make ThingWorx. They were acquired by PTC a handful of years ago. I'll take KepServer EX, I will purchase the Beckhoff driver, I will purchase the Allen Bradley suite, and I'll purchase the Siemens driver, or I'll purchase the manufacturing suite, which gives me all the manufacturing drivers. And I'll take that server and I'll connect to Beckhoff natively over its native protocol. I'll connect to the Allen Bradley over its native protocol, and I'll connect to the Siemens over its native protocol, okay? And then what I will do is I will build out a namespace inside of KepServer that organizes the tags, the information inside those devices hierarchically, all right? So I may create a Beckhoff folder, and I'll create an Allen Bradley folder, and I will create a Siemens folder. Now, the way that KepServer already does that, they create this using the device, they do it automatically, okay? KepServer EX is an OPC server that supports many elements of the OPC UA standard, which I'm gonna do a graphical representation of the OPC standard here in a second. I'm gonna steal something that Jeff Schrader, one of the members of our community, did. It'll look familiar to what he did. Since that's already something he's published, I wanna keep our comparisons in line, okay? So that the community's already seen this, all right? And then what KepServer will do, once I'm connected, I've brought my tags in, I've created my hierarchy, and I'm getting those values updated. What KepServer will do is it will expose the namespace that's running in KepServer using OPC UA. Using the OPC UA standard, Kepware will expose the namespace of all the tags out to any OPC client. Now, in a later video, I'm going to show you how an OPC client under the hood connects to a server and what are all the things that have to happen in order to connect, find the data that I'm looking for, and retrieve that data. Either set up a subscription or do an explicit read to extract it, okay? So the use case that I just gave you is the most common use case for using the OPC standard. However, in terms of the total standard, if I go to opcfoundation.org and I read the entire standard, so I read OPC Classic, which was the original standard written in the 90s, it's based on COM and DCOM. DCOM has gone away, but OPC Classic standard was based on the technology from the 90s and the early 2000s. OPC UA standard is based on technology that was developed in the 2000s and comes to now. I'm going to talk a lot about, you'll hear me say, listen, OPC UA is not the future of IIoT all the time. And in a nutshell, it boils down to really three things, why it's not the future of IIoT. And I'm going to explain that right now. One of those reasons is that because the OPC UA standard has too many remnants of the classic standard, and we call that technical debt in our world, and it makes engineers' job difficult to do these integrations. That's reason number one. Reason number two is that the OPC Foundation, while its mission is for interoperability of industrial systems, in practice, what they're doing is allowing the companies, the corporations who help write the standard, to make it easy for them to sell their products and steer you towards their solutions, and not to make it easy for their solutions to interoperate with one another. Here's an outstanding example, okay? If you go and look at I think there are something like 600 members of the OPC Foundation globally. That is 600 companies, partners who make OPC tools, okay? You would think that if I've got 600 members, I could easily buy all 600 of their tools and I could connect all of them together seamlessly. Why? Because they're all partners, they all help to write the standard, they all sit on the committees, they all write the companion specs together. One would think that if I had all 600 of those people working together and they all made their own product, we could connect all those products together and they could seamlessly interoperate. And the answer is that simply isn't the case. In many cases, products made that have the OPC label on them that only use one part of the specification will not interoperate with another product that's got the OPC label on it that's using a completely different part of the specification. There will be no value gleaned from connecting the two together to try to pass data and information back and forth from one another, okay? That's number two. So number two is the corporations are focused more on how they benefit and less on how the consumer benefits from the OPC UA standard, okay? And number three, the OPC Foundation is a highly bureaucratic organization, and there are many members of the organization who are more focused on their role within the organization as opposed to their providing effective tools, okay? So those are the three fundamental reasons why OPC UA is not the future of IoT. That doesn't mean that OPC, the OPC Foundation doesn't do God's work, okay? It doesn't mean that they're not doing God's work. It doesn't mean that they don't work hard. It doesn't mean that they're not smart. But it does mean that if you chart the path between the mid-90s to now of the OPC Foundation and the OPC standard, they drew an error vector in the beginning that put them going in the wrong direction, and they haven't corrected, okay? So what is OPC, okay? In the subsequent videos, I'm actually gonna chart things out here in the next video, kind of what does an OPC architecture look like? OPC is OLE for process control. That's object linking and embedding, and it's an extension of the Microsoft framework from the 90s, and it's meant specifically for industry. It's a way for applications to interoperate with one another. It was meant to basically create an open industry standard for hardware and software, but unfortunately, that isn't what it is, okay? And we're gonna talk about that in subsequent videos. All right, what is OPC? Part 2, really, key elements and how does it work? Take 0. All right, so OPC. We're going to talk about some key elements and I'm going to sketch kind of how it works, all right? So remember, from the last video, from the first video, OPC is OLE for process control, and OLE is basically how do I make it so that pieces of software that run inside of a framework, and the framework in this case is the OPC standard, pieces of software that run inside of a framework, how can I link objects or events from this place in my software or framework to over here? Okay, that's, think about it this way, the best description is, you know, how can I write a piece of software that runs in a Microsoft operating system that can navigate objects that are running in the operating system itself? Things like a file share. You can download many applications that'll allow you to explore files on a thing. You use OLE to do that, right? You use OLE to do all that linking so that I can take a piece of software and I can browse those types of things, okay? So that's the best illustration, okay? So some key elements of OPC. Number one, the OPC Foundation is the group that is basically made up of companies who make OPC products that meet the standard. They use those products for really two reasons. Number one, to have their products talk to one another. So Microsoft might make two products, a product I sell to this type of customer and another product, an add-on I might want to sell to that customer. And I might use the OPC UA standard to connect those two, to open this product to my other product I'm selling. And I may not use that to make my product, the data from product A, open to a third-party product. I may use it as the underlying protocol and standard for how I'm sharing data between two of my own products. Okay, that's one application. The OPC Foundation is made up of companies who do those types of things. The OPC Foundation is also made up of companies who make third-party OPC products. So that is, I may make a product that talks natively to Microsoft's product A over Microsoft's native protocol, and then converts to OPC, so using the OPC standard, so that another third-party OPC client or piece of software can consume that data. Okay, so that's the second application. Okay, that's a second most common type of application. And then the third type of application is I might make a standalone product that's supposed to interoperate with everything, only other OPC things. Okay, so I don't talk any native stuff. All I do is take OPC from over here and expose it to OPC over there, OPC client over there, right? And I'm the server in the middle. Those are your three use cases. So key elements, the first group is the OPC Foundation. They're the people who write the standards. They're made up of all the companies that make these products. And there are some end users on there, but the end users have very little say in the outcome. Okay, we know that if we plot the history of the OPC from the 90s until now, the end users are really not driving the development. It's really being driven by the corporations that make up the OPC Foundation, and that's why the standard's a fucking mess, okay? Number two, another standard. You have OPC Classic and UA standards, okay? So these are the core standards. The second key element are the basic standards for creating information models, creating an OPC server, for organizing the data, for talking to a client, for responding to a client, for keeping connections alive, handling timestamps, all that kind of stuff. okay? So the second piece are the base standards, okay? The OPC UA standard, which came out in the early 2000s, the OPC Classic standard was based on COM and DCOM. That was the underlying technology in the 90s that was predominant in Microsoft products, COM and DCOM. The OPC Classic was based on that technology, and it was fairly simple. It was a simple way of organizing data, creating a hierarchy, and exposing it to other applications, all right? Interoperability. Again, remember when we talk about OPC, we're talking about process control. How do we do this in industry? How do I take stuff from machines and share it? Microsoft already had their own standards, used for OLE, that's object linking and embedding, for commercial and consumer products. They already had that. OPC is for machines specifically, for industry specifically. So the second element is the base standards. The common standard now, the one that nearly all products that come out have, is using the OPC UA standard, okay? That standard was originally 13 parts. Then you added OPC part 14, which was PubSub, and I don't know how many parts we're at to now, part 20, I think, or something. And then the third piece, so this is the core OPC UA standard. So the second element is the standard itself, and then the last part is companion specs, okay? Companion specifications are offshoots of the base standard that tell you how to organize data. The best way to define most companion specs in the UA standard is it's a specification that tells you how to create a user-defined data type for a specific type of equipment. Okay. Now in OPC UA and OPC, they call these information models. They should not call them information models. They should call them data models. They're not information models. The data hasn't been transformed yet. Remember, information is transformed data. What they really are is hierarchical data models. That's really what the companion specs create. Again, I don't want to get too technical. This is meant for a broad. But the companion specs are really specifications that tell you how to create a user-defined data type, okay, for a specific type of process. Okay, CNC would be a really good example, or a lathe would be a good example, okay? The three key elements that make up what is OPC is the foundation, okay, made up of the companies who make these products, okay? The two base standards, OPC Classic, which is deprecated, you will see this less and less and less, the utilization of it, the OPC UA standard, which we talk about all the time, and then the companion specifications, okay? What I'm gonna do is show you, in a nutshell, what the core of the UA standard is, where most OPC UA solutions start, where they start, and then we'll talk a little bit about what makes up the UA standard here in a second. All right, so how does OPC work in general? The common use case, okay? So the common use case in OPC is I have two things. I have an OPC server, okay? And I have an OPC client, okay? The OPC server is the thing that has the data, and the OPC client is the thing that wants the data. Okay? The OPC UA standard has many, many, many pages of rules for if I'm going to build an OPC server, how do I build it? Okay? So there's components of the UA standard that tell you how to build an OPC server. There's basically, for the rank and file, here are the things that matter. You have your objects, and then you have your topics. Okay? Topics will be tags. Objects give you part of the hierarchy. How do I get to my thing? And the topics live in a place in the hierarchy, but they can live in multiple places. A topic's also an object, tag object, right? So the standard shows you how to build an OPC server so I can serve out my data. I may have 100 tags that I've retrieved from a machine that are like temperature and level, and I did those over serial communications to that machine. I wrote my own custom driver. I extracted the data from the machine. I've got it running in a piece of software, and now what I want to do is make that data available to some other piece of software. If I want, I can use the OPC UA standard to create an OPC server, and then I can create an OPC client to extract that data, okay? There are rules to build an OPC client, and there are rules to build an OPC server. And you can use the OPC UA standard to do that. Now, I can also do things like, I could use the companion spec, let's say the 100 tags that I retrieved from my machine. In this case, let's say there's a CNC companion spec. I haven't read them all, not all the companion specs. But let's say I've retrieved data from a CNC machine. Okay, and we have a CNC companion spec. I can also take the CNC companion spec and I can put in, using the companion spec, the CNC info model. I'm almost certain there'll be one. If you're making information models for anything, you'd start with CNCs. I could use the CNC information model from that companion spec, if it exists. Vaughn will look it up and tell me if there is one. And I will use the base standard from the UA standard to create my server, and I will use the base standard from the UA standard to build my client. There is a CNC companion spec? Okay, good. I wasn't wrong, there is. So I could use the companion spec for CNC data to create the information model, map the appropriate tags from the 100 that I retrieved from that CNC into a CNC information model using this spec, so that I could then, this client could establish a connection to this server. It could then browse the OPC namespace. It could retrieve, it could set up a subscription to the CNC information model, and then the server would update the client about the data inside the CNC information model, and this OPC client would then be connected to a user interface that could monitor the changes of those values and display the data from that CNC. Okay? So I know that's messy now, but in a nutshell, that's how OPC UA that's how OPC works in nearly all use cases. Okay? So that's a very good example of a OPC use case. That's a great use case right there. Okay? What's the problem with what I just put on the screen there?
You selectively pick components of the specification to build your application.
I didn't use all the specification, right? I only used the pieces of the spec I needed for the use case, okay? It's linear integration, right? Data from the machine to my OPC server where I'm going to convert my data to my OPC client. I have to allow my client permission to connect to my server. I have to open inbound ports to get down there because the connection is instantiated by the client, okay? The response comes from the server, but the connection's instantiated from the client. If my client is at a higher level in the organization, that client has to have permission to talk down to retrieve my data, okay? So what I'm going to do is I'm going to show you, I don't know all the elements of the spec without reading the spec here, but I can give you, I'm going to go ahead and use Jeff Schrader he made a satirical diagram on OPC. What is OPC in the standard? And I'm going to go ahead and show you guys that. But I'm going to do my own thing. So you've got OPC core, okay? So you've got OPC core, which they don't call it core, but we're talking about the layperson. You got the core element of OPC, okay? And that is server client. That's a thing that's used nearly all the time. And then you've got all these other things. Oh, you put it up there for me. So you've got, but here are all the things. You've got HDA, you've got XMLDA, you have alarms and events. So
auto discovery.
Yep. You have auto discovery. Okay, all these elements of the OPC, that core OPC UA spec, okay? You've got SOAP, okay? And credit to Jeff Schrader, because I'm looking at Jeff's document up here. He kind of put it together in a chart. Payloads, okay, which by the way would be part of server client. You've got DA. Okay, so you got all these things. Now, obviously TCP is going to be our communication of choice, and we've got UDP, okay? And then we've got other elements of the spec, okay? Here's a fundamental problem with what I put on the screen there. If I'm going to build an OPC solution, I want to use OPC UA as my IIoT standard, okay? Well, the first thing I need to do is I would have to learn the standard, and then I'd have to build a tool that used the entire standard, okay? And by the way, that tool doesn't exist. There's not a single product on the market that uses every single piece of the standard. Nearly every tool that you buy, of the 600 members out there, they're going to have this piece, okay? They're going to have TCP. You could build a product that's just this. Oh, you would need payloads. So let's do, we'll do payloads up here, right? How do I I could build a product that only uses the core elements of the UA standard, only uses the elements of TCP so I could communicate, and how do I exchange payloads? I could create a product that does that, okay? HDA is how do you transmit historical data, so how do I reply with payloads that have historical data in them? This is alarms and events. This is auto discovery of elements. By the way, that came out in, credit to Matt Paris, came out in 2012. And, basically no one implements, right? SOAP or HTTP interfaces, XMLDA, very common in Siemens motion controllers. Like if you go look at the D445s from Siemens, they have an XMLDA server that runs on the D445. Here's the problem, okay? The problem is that there's no tool out there that has all these things, okay? And I could make a product that only uses a couple of the elements that doesn't work with another product that doesn't use those elements, okay? So one of the fundamental issues with OPC UA is when I said in the live stream that there needs to be elements, more of the OPC UA standard needs to be compulsory. What I'm saying is that if we're going to say that OPC UA is an IIoT protocol, that we want to use it as the core of our IoT infrastructure, then we have to make more elements of the OPC UA standard compulsory. And by the way, this is the OPC Foundation's fault. And when I say the OPC Foundation, I mean the companies, the people who make up the OPC Foundation. Because one of the roles of the OPC Foundation, they have certification committees. So if I make an OPC product, okay, they certify the product before I can put the label on it. And for whatever reason, the OPC Foundation if the goal is interoperability, they're doing a terrible job of creating interoperability. But if your goal is interoperability for products only your members make, okay? And moreover, if the goal is to make interoperability for products that a member makes, so Microsoft wants to use OPC so that my products talk to one another leveraging OPC, but we're not going to go ahead and, we'll put that in a wrapper and not expose it to third-party applications. The OPC Foundation does a phenomenal job of that, okay? All right, so what is OPC Part 2, okay? You remember the three elements, the OPC Foundation, the core specifications, the companion specification. I showed you the example of the typical use case, the most common use case. If you see OPC, the use case I just showed you is the absolute most common use case you're going to see. There are many other use cases out there. I don't want that use case I wrote over there, but for the lay person, if you want to know what is OPC, that's the most common use case.
That was my
okay?
use case.
Okay, that's the most common use case. And then remember, why is it that OPC UA, why is it most people don't, there is no product out there that encapsulates everything that is the standard, okay? There's too much technical debt in the standard. There's also conflict. There are pieces of the OPC UA standard that you could implement. That's right, where you've got to choose. You got to make a binary choice between one or the other. Okay. There's too much technical debt in the application. And the last piece is, if I want to build the OPC UA solution, I'm spending buco dollars. Buco. Okay. All right. So that's OPC. Now let me say this, because I don't want to make enemies of the OPC Foundation, although I do take a ton of heat from those guys. I can handle it because I probably know the spec better than they do. What does the OPC Foundation need to do from a consumer perspective? What needs to change? Okay. Number one, there needs to be more voices from the user side. Okay. So that is engineers who are using tools made by the 600 plus corporate members. There needs to be more of a voice in writing the specifications and writing the certifications, okay, for those products. Number two, you got to strip the technical debt out of the existing specification. Number three, you got to nuke Part 14, which is PubSub, we'll talk about in a little bit. You got to nuke it and start it from scratch. You can't start it from scratch until you strip the technical debt out of the spec. You got to nuke it and start it from scratch, okay? And I would say I'd add a fourth piece, okay? The OPC Foundation has to be focused on making it easier for companies to build OPC tools quickly with the singular focus of interoperability of data between unrelated partners. third party to third party. Okay? All right, that's my story and I'm sticking to it. What is MQTT? Take 0. All right, if you guys have been watching our content for any amount of time, you know that the primary protocol that we work with, the primary standard we work with, is MQTT version 3.1.1 using Sparkplug B. So what is MQTT? Okay, MQTT is messaging queue transport telemetry. It was invented in the late 1990s by two people, a guy named Arlen Nipper, who everyone should be familiar with. He's a really very famous, world famous engineer, and another guy named Andy Stanford Clark, who worked for IBM. Arlen Nipper and IBM, so Arlen Nipper and his company, I can't remember what the name of the company was, but Arlen and Andy worked together with Phillips 66 in the late 90s to create a new industrial protocol that would jump a couple of major hurdles that the oil and gas industry was dealing with. If you haven't worked in oil and gas, okay, but you've worked in, say, water, wastewater in Southern California, you're already familiar with some of these problems, right? The network infrastructure in oil and gas, oftentimes the sensors, the instrumentation that you want to extract data from is in very remote locations. So to access it, I'm either accessing it through serial networks, low bandwidth free wave radio systems, satellite, VSAT, that kind of stuff. And I have very low reliability on those networks. So A, I can't check for my data very frequently using a traditional technology because I don't have enough bandwidth. B, when I do check, I don't get a response very often because the network is really unreliable. What Phillips 66 wanted to do was they needed a protocol, they needed a technology that allowed them to monitor their remote assets as if they were inside of a facility that had a fiber optic backbone. So they needed to be able to collect their data in a way where they could pull for it very, very quickly and very reliably. Arlen Nipper and Andy Stanford Clark invented MQTT to solve this problem. Messaging queue transport telemetry. How does it work? Okay, very simple. What they did was they created a technology where I have an MQTT broker, okay? That broker is in the middle. They took all of Phillips 66 assets out here, and so for all of their assets, they installed an MQTT client, okay? They created a very, very lightweight protocol that in a nutshell, at its core level, is topic and payload, okay? So the topic will be the structure of the data. So in this case, let's go ahead and do P66/site1/temp. And the payload would be whatever the value of that payload is. In this case, let's do 71 degrees. Now, that payload can be anything. It could be a JSON. It could be, I could publish any type of context in there. I could create a JSON that looks something like this, temp, so key value pair, temp 71, comma, pressure, 14 bar, and then close the JSON. I could do that as the payload, timestamp, okay? So at a nutshell, the way MQTT is I have a topic and I have a payload. So what they did was they created broker technology that organizes all the data in a topic namespace. So P66, site 1, and then under site 1, I have a topic called temp, and if I look at it, the value right now would be 71, okay? Now what I've done is this will be site 1, and this will be site 2. I install an MQTT client at my sites. I monitor all my instrumentation out here. And whenever the values change, I publish an update to the broker on that value, okay? So if the temperature in site 1, every time the temperature changes, I publish to the broker, my connection to the broker, hey, topic P66 site 1 temp has changed, new value is 71. Report by exception. The client, the MQTT client, if the next time it checks the sensor, the value is 71, it does not publish an update, okay? And what we're looking at here is raw MQTT, MQTT 3.1.1, the basic MQTT. If I add site 2, so I bring site 2 online, the first thing I'm gonna do is I'm gonna configure the client to connect to my broker, and what's gonna happen is site 2 is gonna show up in my namespace. And if I add an instrument called temp, and I want to publish the value, temp, with whatever value, let's say it's 70 degrees, will show up in the namespace, okay? That is MQTT client, MQTT broker in a nutshell. where the clients are only publishing to the broker. I may add a third MQTT client, okay? And this MQTT client, its primary responsibility is, let's say I want to visualize the values of these two temperatures. So I want to be able to navigate to site 1 and look at its temp, navigate to site 2 and look at its temp. I will install an MQTT client. I will connect to my broker, a stateful connection. If Arlen was here, he'd get into all the details. I'm trying to keep this for the layperson. So I'm going to instantiate a connection to the broker. And what I'm going to say on that connection is, I want to subscribe to everything, okay? So I'm going to send a subscribe command with a wildcard of a star, okay? And what that means is I want to be notified when anything changes in the namespace, okay? So let's say the temperature changes from 70 to 71 here and from 71 to 70 here, and they publish those two changes. Here's what I'm going to see on this client. P66, site 1, temp, and site 2, temp, okay? As this value changes, I will be updated. My client out here will be updated. Let me show you one more thing. Let's say I add a third site. I add site 3, and I connect to all my instruments, and I point to my broker, and I say, we're gonna publish everything as it changes. And in this one, I just put a flow instrument, okay? As soon as the flow changes, I'm gonna see site 3 here, flow, and whatever the value was. And because I've subscribed to everything in the broker, this MQTT client is gonna see site 3 and flow, okay? So that's your core MQTT. What is MQTT? The key elements, okay? MQTT is message queue transport telemetry. It is a lightweight, edge-driven report by exception protocol, okay? It is open. The standard is managed by the Eclipse Foundation. If you want to see the MQTT 3.1.1 standard, I think it's something like, it's a very short standard. It's a broker technology that was built for industry. If you go to Phillips 66, all of Phillips 66 underlying technology is MQTT, okay? A couple of important things, okay? This is a 10,000 foot view of what is possible with MQTT. Okay? And it is the bare bones. This is MQTT 3.1.1. In the next video, I'm going to talk about Sparkplug B. So what is Sparkplug B? We're also going to talk about MQTT 5, the newest standard for MQTT, okay? Which came out in 2019. But before I do that, I want to highlight a couple of major advantages, strengths of this technology, okay? Number one, if these clients out here are out on these are my assets in my plant, okay? One of the biggest risks you have in industry with the previous OPC UA infrastructure I showed you guys is that I have to make my assets vulnerable by opening inbound ports in order to talk to them over native protocols. Using this architecture, you do not, okay? I can put a firewall here, okay? And with that firewall, all I have to do is allow outbound connections from the MQTT client to the MQTT broker, okay? Outbound connections only, by opening a single port. All responses from the broker will return through the same outbound port where the edge client established the connection with the broker, okay? Number one. Number two, an MQTT client can be both a publisher and a subscriber. So what I can do is from my MQTT client out here, which is predominantly subscribing to the data that we're sending into the broker, I can also write new values back, okay? So I can take these values, create information with them, and then publish them back into this namespace with a new value. So let's say what I wanted to do with this MQTT client is create an array that had the last 10 values of this flow. I could create a topic called flow array here, and I could publish it here into flow array, so someone else could subscribe to that, okay? But also, I could write to set points that the clients out on the edge could subscribe to so that I could change set points, just like in standard OPC architectures, okay? That's the base of MQTT. What is MQTT and how does it work? In the next video, we're gonna talk about the MQTT 3 standard, the MQTT 5 standard, and Sparkplug B, and why they matter, okay? All right, what is MQTT Part 2? Take 0. All right, so this is the second video on MQTT. What is MQTT, right? We're revisiting after a couple of years, primarily because we want to go over Sparkplug B and MQTT 5, okay? If you haven't watched the first video on what is MQTT, or you haven't watched the videos before that, which is what is OPC and OPC UA, go back and watch those videos, okay? In this video, we're gonna go over key elements of MQTT, some things that you need, if you want to know about MQTT, there are some key elements you need to know about, and then I'm gonna sketch like what the MQTT stack looks like, okay? All right, so key element number one about MQTT is, I really should have put a previous one, which is where did it come from? In the last video I talked about that. It was invented by Arlen Nipper and Andy Stanford Clark from IBM, and Arlen, I can't remember what company he was with, but they were developing a new industrial protocol for Phillips 66 in the late 90s. It ended up getting adopted in consumer technology. So Phillips 66 widely adopted it, completely transformed their business because it's lightweight, edge-driven, report by exception. It basically were able to retrieve massive amounts of data, all of their telemetry data over very slow and unreliable serial networks, okay? That's where MQTT came from. That's its origination, okay? Late 90s. During the early 2000s and into like 2010, 11, and 12, MQTT really spread out through like the hobbyist community. It was adopted by Facebook. If you look at Facebook Messenger, anywhere where you see the ellipses being used, where if somebody else is typing and you're seeing the little dots, that's MQTT. Under the hood, it's because MQTT clients that connect into brokers, those are stateful connections. And so when I'm typing and I'm messaging Zach, Zach's messenger client is subscribing to a topic from our connection, which is whether I'm typing. If I am typing, they're getting notified from the broker that I am typing, and their application on the other end is creating those ellipses, okay? Zach doesn't have to check. He doesn't have to keep checking to the broker to see if I'm typing. The broker is notifying him that I'm typing, and I am notifying the broker that I'm typing while I'm typing my keyboard, okay? So MQTT is everywhere around you. Google Nest uses MQTT in many places. It's under the hood. A very, very common place that MQTT is used in the automotive industry is cars will connect to the internet and publish payload data to central brokers over MQTT. Very, very common, okay? MQTT didn't start getting widely adopted in industrial applications until like 2010 to 2013, in that area. Over the last 8 years, it's absolutely exploded, and MQTT is the industrial IoT protocol on the planet. It's the #1 most popular IIoT protocol on the planet, okay? So you need to know the inventors, Arlen Nipper and Andy Stanford Clark, and where it came from. Number 2, Oasis Open. You need to know Oasis because that's where the MQTT standards, that's where they're written, that's where they're approved, and that's where they're maintained. So if you want to read, there are basically 2 MQTT standards. You have MQTT 3.1.1, which was approved by Oasis in 2014 and has been administered by 2014. If somebody says MQTT to you, they're almost certainly talking about MQTT 3.1.1, that version, okay? In 2019, Oasis approved the MQTT 5 standard, which it's backwards compatible to MQTT 3.1.1, but it's added in a bunch of additional features, okay? All right, for the 3.1.1 standard. So I strongly encourage that you go to Oasis Open and you read the 3.1.1 standard and the MQTT 5 standard. So you need to know Oasis Open, the people who manage the standards, Oasis. You need to know the 3.1.1 standard. You don't need to know the standard, the products all work easily. But if you want to know what works under the hood, go look at 3.1.1 and MQTT 5. The Eclipse Foundation, okay, is the body that manages the Sparkplug specifications. So these are in order. Okay? The Sparkplug working group at the Eclipse Foundation is made up of companies like Flow Software, Canary Labs, Cirrus Link, all the companies many of the companies that make Sparkplug B tools. That working group is the one who drives the Sparkplug standard. So I'm gonna explain Sparkplug here in a second, okay? So the Eclipse Foundation manages the Sparkplug standard, which is the MQTT standard for industry. So when I'm doing an MQTT solution, right? I want to use MQTT to connect all the nodes in my business together so that I can share data and information openly between all the nodes in my business. What's a node? A node could be a PLC, it could be an MES system, it could be your ERP system, it could be your CMMS, it could be anything else. It could be a piece of test lab equipment, et cetera, et cetera, et cetera. It could be people. What you want to do is connect those all together in this hub and spoke architecture with a unified namespace in the middle. That unified namespace is generally a broker. Most times it's MQTT broker, where the data, the topic namespace, is organized like your business. Imagine it like a file share. I want to be able to go to a file share and navigate to Phillips 66, site 1, device A, and I want to look at all the tags in there. And then I want to go back up to site 1 and look at the topic called operational efficiency or total production. Imagine having the ability to do that. You do that with MQTT. The infrastructures that we create, we do that using MQTT. We don't do that using OPC UA, okay? All right, so in an earlier video, we kind of showed you one of the reasons that OPC UA is not an IIoT protocol, and a lot of it has to do with the fact that the standard tries to be everything to everyone, and therefore it's nothing to everybody. So go back and watch that video, and Jeff Schrader did a great example of all the options in the standard that basically no one ever puts in. MQTT is pretty simple, all right? On the bottom, you have MQTT3 and you have MQTT5, okay? Those are the core standards, okay? There's only a couple of optional elements in either of those standards, and they are backwards compatible. So I can, MQTT5 builds on MQTT3, okay? So when we look, MQTT5 clients should be able to talk to MQTT3 infrastructures, okay? MQTT5 has a couple of major additions. So from 2014, MQTT3 was adopted. 2019, MQTT5 was adopted. Here are some examples of changes that they made in the MQTT5 standard. They added in the ability to both the client and the broker to disconnect a TCP connection. It used to be just the client could do that. Now they're allowing the broker to disconnect the connection to the client and notify to the client that they're going to disconnect it. Okay. They added in authorization codes. They added in reason codes in the headers. They've added in basically the ability to send metadata in a publish, a transaction, or a subscription. You could add in metadata to provide some additional context without having used the topic payload to create the context. They added in some things like that. Okay. But the vast majority of the stuff you see in the world right now is MQTT3 solutions. Okay. So you've got MQTT3, you got MQTT5, and then on top of that, you basically have, we'll just do Sparkplug B. There's a couple of, you could do raw flat MQTT, we call it flat, where I'm just using the MQTT3 standard for my clients to talk to my broker and vice versa. I could use just the MQTT5 standard, okay? Or I could put the Sparkplug B standard on top of MQTT3 or 5, okay? Sparkplug B adds in, the two major things that Sparkplug B adds in is like industrial hierarchy and compression, okay? The Sparkplug B standard is managed by the Eclipse Foundation. That's where the user group is, the Sparkplug B user group. Arlen Nipper, the inventor of MQTT, his company is one of the companies that's part of the Eclipse, or the Sparkplug B. Sparkplug B was basically added in to tell, because MQTT is used in both consumer and industrial applications, Sparkplug B was the standard written by Arlen Nipper and his team to tell industrial users, hey, here's how we recommend you use MQTT to transmit industrial data. That's what the Sparkplug B spec is. It's about 70 pages long. It's very, very easy to implement. We at 4.0 Solutions wrote our own MQTT Sparkplug B transmitter using PAHO Python libraries. It was very easy to implement, took less than a day, okay? This is why you see such wide adoption of MQTT across the market, because it's so easy to implement, okay? That's the number one reason. So, by the way, this is the MQTT stack here. You got the MQTT3 standard, you've got the MQTT5 standard, and then you really have Sparkplug B. Now, there is a Sparkplug A, which was the first version of the standard. Here are some things that Sparkplug also added in. UDT support. They call it template. So basically what Sparkplug B does is it tells you how you can use MQTT to send UDT definition in your payload. So I can, instead of just sending flat tags, right? P66, site1 temp, instead of just P66 / site1 temp, I can also send a temperature definition in there. So say this temperature is a user-defined data type that has a bunch of attributes underneath it, and it's basic, think of it as a class in regular software development. Sparkplug B gives me the ability to send the definition, okay? Why do I bring that up? I normally wouldn't talk about this kind of thing in a video for lay people. Here's why. When we talk about companion specifications in OPC UA, companion specifications are generally, they call them information models. They really should be data models. They should call them data models. The companion specs are generally a separate specification to tell you a separate specification that tells you how to construct and send basically a user-defined data type using OPC UA. With MQTT, the way they do it is they use a common standard. Instead of having 100 companion specifications, one for each UDT that you want to send, they have a mechanism in Sparkplug B to tell you how to flag something as a user-defined data type, to say, this is a template. It's a model that I am publishing to the broker. The broker will consume that and say, and know, hey, that's a model, it's a template. And it can notify other clients, Sparkplug B clients, that, hey, this is a template, it's a user-defined data type, and therefore you should treat it as such, okay? With OPC UA, you have to implement the companion spec on one side for that specific information model, CNC, for example, and then I've got to be using a client that can consume the CNC information model by implementing that specific companion specification. So one of the big advantages of MQTT over OPC UA is that in general, OPC UA uses companion specifications to tell you how to create a user-defined data type for a specific process and how to consume it. In MQTT, we use Sparkplug B to just flag that, okay? All right, so that's basically your MQTT stack. That's as easy as it gets, okay? And here's the other beauty. Let's say that I've got an MQTT broker out here, okay? I've got a broker. Actually, let me do it differently. I have an MQTT broker here, okay? And I have a MQTT 3, an MQTT 5, and a Sparkplug B client, okay? This client right here is the only one that can decipher a Sparkplug B payload, okay? This is the only one that can support the deciphering of reason codes and authorization topics that are included in MQTT 5. And this one only talks flat vanilla MQTT 3, this client. The beauty of MQTT is that my broker can support all three. All MQTT 5 and 3 are, so Sparkplug B is, the underlying structure of MQTT doesn't change with Sparkplug B. Here's what Sparkplug B does. Sparkplug B says this. When you connect a client to a broker, you're going to create a birth certificate and we're going to manage death certificates. Why? It really boiled down to Sparkplug B added in the support for us to monitor the health of connections, okay? Before, you had to rely on the MQTT broker, whoever implemented the broker, to include that feature. So EMQX, IMMQ, whatever. Are they monitoring those connections, right? The health. Sparkplug B with birth certificates and death certificates, Sparkplug B gave you the ability to monitor the health of connections based on the number of births you see. Number two, Sparkplug B gave you the ability to create industrial hierarchies using group IDs, node IDs, right? I can take namespaces from multiple devices and send them to the same group, and the group would be my plant. So let's say I had a broker at my organization and I have 12 MQTT clients inside of one facility. I can assign a group ID for that specific facility, facility A. And I can say, hey, Sparkplug B client 1 through 12, your group ID is facility A. And what I'll get is facility A with all 12 groups and all their namespaces, right? Sparkplug B also added in support for compression. It added in a bunch of other support too. But for us, the three big ones are sending UDTs, that is actual definitions as payloads, individual hierarchy, and compression. That's Sparkplug B. MQTT3 is all the native basic MQTT technology. Here's what a client looks like, here's what a broker looks like, here's how you publish, here's how you subscribe, this is what quality of service is, etc. MQTT5 took some of the advantages created with Sparkplug B, written by Arlen Nipper and his team and now administered by the Eclipse Foundation, and added in some of those things natively into MQTT5, plus some other stuff, okay? But the beauty of the way that this is managed is that the focus of the people who develop MQTT has been to create an edge-driven, lightweight, report by exception, open standard from day one. And if we contrast that with the OPC Foundation, right, what is their goal? Their goal is, tongue in cheek, but what's the ultimate goal? It's not really open. The ultimate goal is interoperability between their members' applications, right? Or more importantly, interoperability between a member's applications at the OPC Foundation. So if you want to know why we're so high on MQTT, part of it's philosophy, right? Philosophy of the people who invented the technology. Arlen and Andy gave MQTT to Oasis to administer, and Arlen's team gave Sparkplug B to the Eclipse Foundation to manage. Okay, Arlen doesn't own Sparkplug B, and he doesn't own MQTT. He doesn't have a patent on MQTT. He doesn't get paid for every implementation of it. He's literally turned it over to the community. Okay, and then what does CirrusLink do? They build solutions that support his open, community, democratic protocol and standard. Okay. Let's talk from a practical sense. So why are we so high on it philosophically? Let's talk about it practically, okay? Because it's edge-driven, I can scale my applications better because it's more lightweight. I can scale my applications better because I don't have to deterministically take someone centrally and go, oh, I added a machine. That machine's on the plant floor now. I need to add it here into my infrastructure. What I can do is tell all my machines to notify me that they've been added. So as I add new equipment, they show up in the infrastructure. You can't do that with OPC UA. Well, you probably could using auto discovery if anyone ever built it, okay? The fact that they haven't built it should tell you everything about it. Okay, that's number one. Number two, it's report by exception. So the things that we're publishing are only things that have ever changed. We don't waste overhead on stuff that hasn't changed. Number three, it's completely open architecture, okay? I can build my own MQTT client. Here is a really good example. I want you to Google MQTT broker, MQTT client, and find out just how many free MQTT tools there are out there. And then I want you to do the exact same thing for OPC. I want you to try and see how many free OPC clients there are, how many free OPC servers there are out there, and then compare to how many there are with MQTT. Okay? The reason that matters is this. It goes to philosophy and it goes to architecture. The philosophy of the people who build MQTT is open, MQTT tools, okay? Number two, because the specs are, in my opinion, they have no technical debt, okay? Because they're so new, right? The first MQTT spec that's been used in industry was developed in 2014, unlike with OPC Classic, which was developed in the mid-90s. Okay? Look how much technology has changed since the mid-90s. Because of that, it's easy to develop very inexpensive tools that you can just give away to people for free. Okay? All right. So anyway, what is MQTT? Key elements. The key elements are, remember, the inventors, Oasis Open, who manages the core specs, the Eclipse Foundation, who manages Sparkplug B. That's also where the Sparkplug working group is, headed up by Arlen Nipper and his team at CirrusLink. 3.1.1 was the original MQTT standard that everyone started using in industry in 2014. Sparkplug A and B were the industrial standards. How do you take MQTT? 3, the base 3, and be able to ship UDTs, create industrial hierarchies, and add compression, plus a bunch of other things to Sparkplug B. I encourage you to read this spec. It's only about 70 pages long. A big light bulb will come on when you read it. And then MQTT5, which is the latest standard adopted in 2019, that added a bunch of new features. By the way, I want to say this. If you look at how MQTT standards are changing, are evolving, from MQTT 3 to MQTT 5, there is one thing that stands out above all else. Focus on industry. And that's all you need to know. What you really need to know is that if you watch how the standards are evolving, they're all fully backwards compatible, but if you look at how they're evolving for industry. And that's all you should need to know about which is being more widely adopted, MQTT or OPC. Warm-up video. All right. What is Sparkplug B for MQTT? Take 0. All right, in this video, so if you have not gone back and watched the 2 videos from about OPC UA and the 2 videos about MQTT, which were released in August of 2021, go back and watch those videos. Very important. In this video, we're going to go over Sparkplug B. What is it? How does it work? This is a video for the layperson. We're going to do a 10,000 foot and a 5,000 foot discussion, but we're going to get into some technical details, okay? I'm not going to go deep into the weeds so that we have people's eyes glaze over, but we are going to get into some technical details, all right? So what is Sparkplug B for MQTT, all right? Key elements, okay? We've already gone over this, but some things I want to point out. Sparkplug B, the Sparkplug B specification, which you can Google, MQTT Sparkplug B, is managed by the Eclipse Foundation, okay? It was developed, the Sparkplug B spec was written in 2016 by CirrusLink, which is a company owned by the co-inventor of MQTT, Arlen Nipper. They turned over that specification to the Eclipse Foundation in 2019, okay? The Sparkplug B specification is a specification for packaging up industrial data and communicating it to a MQTT infrastructure. Okay? It is based on the MQTT 3.1.1 standard. So one of the first things that you learn about Sparkplug B is that it's an extension of the base MQTT 3.1.1 standard. So obviously there will be a new release of the Sparkplug standard for MQTT 5 at some point. MQTT 5 was released in 2019, hasn't really gotten wide adoption yet. There are some key elements we're going to talk about here. So I'm going to talk about group ID, edge node ID, and device ID here in a minute, okay? What's important to note is that we can package up MQTT payloads, okay? We can group them together and we can transmit them to a broker all packaged up nice and tidy instead of publishing individual topics to our broker, okay? And I'm going to get to all this here in a second. So group ID, edge node ID, and device ID are important concepts. They're key elements. It's basically the logical grouping of your topic namespace. Supports store and forward. So if the MQTT client that you're using that implements the Sparkplug B spec, this is how you get store and forward, standardized store and forward with MQTT using the Sparkplug B specification. What is store and forward? I have an MQTT client out here on the edge. I've got all this stuff changing. This is connected to sensors. I've got all these values changing and this connection breaks, okay? So that I can't get the data to the broker and I got all my consumers out here. This breaks. Store and forward means is that what we're going to do is we're going to go ahead and store all the events locally on the client, and when this connection's reestablished, we're going to go ahead and publish them all to the broker with the correct values and timestamps in the order that they happened. They basically stream up in the order that they happen, and because the timestamp of the value that gets to the broker comes from the clients out here, it looks to them as if that disconnection was never there, okay? Store and forward. Another important component. Sparkplug B specification has support for templates. What does template mean? It's user-defined data type. Templates in Sparkplug B, okay, a UDT, it's basically a data type object. A template in Sparkplug B is the equivalent of a component spec in OPC UA. We have support for compression in Sparkplug B. So what is that? Is that Sparkplug B has support for us compressing the payloads and sending them to the broker. And the most important concept to understand with Sparkplug B is we create edge of network nodes, okay? And that's where I'm going to start. So remember this, Sparkplug B equals edge of network node, okay? We're going to create infrastructure. So in order for me to explain what this is, let's start with the normal MQTT, which we talked about in last month's videos, okay? So I've got my client, and I have my client who has established my connection to my broker, and I have subscribed to everything with a hashtag. That means everything that's in the broker namespace, I want you to send me the updates to. With normal MQTT, we call it vanilla MQTT, so version 3.1.1, this client can do, I could do things like, I have two companies, right? I've got Intellic, and I've got Intellic, Dallas, and Temperature, okay? I can publish Intellic, Dallas, Temperature to our broker, okay? The value, whatever, today it's 97 degrees, so the value would be 97. If I'm subscribed to everything, I'm gonna get that notification, okay? 97. At the same time with MQTT 3.1.1, I can also do this. I could create a new namespace, and I could have 4.0 Dallas and Temp, and I can publish these separately. Okay, so I'm going to establish my connection, and I can publish both of these separately, flat into my broker. So 4.0 Dallas Temp, and let's say the value is 100, even though they're both in the same city. So I would end up with 1, 2, 3, and 100 degrees. I would get notified.
4.0 is a little hot.
Okay, 4.0 is a little hot. All right, that's your vanilla MQTT. The beauty about MQTT 3.1.1 is that I can create a topic namespace that I can basically piece together my unified namespace, okay? I can take values from sensors, and using 3.1.1, I can basically publish those values to basically anywhere, okay? What does Sparkplug B do, okay? So what I'm gonna do is I'm gonna create a Sparkplug B client, okay? So the difference between an MQTT 3.1.1 client and an MQTT Sparkplug B client is the MQTT Sparkplug B client is also an MQTT 3.1.1 client. Number one, okay? Why? Because Sparkplug B is an extension of 3.1.1. So it's very important to note, if I'm a Sparkplug B client, I natively support 3.1.1 as well, okay? Because Sparkplug B is an extension of MQTT 3.1.1. What I'm doing with Sparkplug B is I'm creating an edge of network node. Okay, so what I'm doing, number one, my goal is to create an edge of network node, which basically does this. It creates a place in, we'll just say these are edge devices, okay? So these will be Sparkplug B devices. So in my topic namespace, I've got this thing called Sparkplug B edge devices, okay? What I'm gonna do with Sparkplug B is I'm gonna package all my data up for one transmission, okay? So I'm going to create my connection, okay? And I'm gonna build my topic namespace, okay? So these are all my tags. My, let's say temperature, let's just list them as sensors. Sensor 1, sensor 2, okay? Now what I'm gonna do is I'm gonna configure Sparkplug B to send my values to the MQTT broker. And this is what it's gonna look like. I'm gonna give it a group ID. So in my configuration, I'm gonna give it a group ID. And in this case, I'll say the group is Intellic, okay? So the group ID in this case is Intellic. I'm also gonna give it an edge node ID. I don't have to, these are optional, edge node or device ID. But I'm gonna give it an edge node ID, and we're gonna call it whatever this edge node is. In this case, we'll say it's Dallas thermostat. And when I establish this connection, I wanna avoid too many of the technical details, okay? There's some things that are gonna happen when I package this all up, okay? Out here in this Sparkplug B client. What's gonna happen is we are going to establish a berth that is this edge of node, this edge of node, wait, this is edge of node device. Yeah, edge of network device, or node, yep. When I go ahead, I'm gonna do ahead and do a berth, which is this is part of the spec, which will be stored in this namespace. There's a bunch of topics that are native to Sparkplug B. I'm gonna do a berth, and then I'm going to give it a group ID. In this case, I'll give it an edge node ID, Dallas thermostat, and then my sensors will be published here, okay? Sensor 1, sensor 2. If my client out here supports at Sparkplug B, it will be able to decipher this topic namespace. How does this topic namespace look like when it's raw? What does it look like when it's raw? Well, they use protocol buffers. So Google Protobuf I know is one of them, and they use another one that's optional. They use protocol buffers to send this data over the wire, okay? If I don't support Sparkplug B, I can't really decipher what this is. Okay, if I just look at it with an MQTT 3.1.1 client, I subscribe to it, it's just going to look like a jumbled mess. You can kind of see a couple of the what some of the stuff mean, like you'll be able to see the edge node actually in the JSON, but it'll be a jumbled mess, okay? So what I'm doing with Sparkplug B is I'm creating an end of network node. I'm packaging everything up together, and there's some technical elements like birth certificates and death certificates that don't exist with 3.1.1, so that up here, what I can do is group all these edge of network devices together, okay? So I can group many devices into the same group. So I could use my thermostat, I could use my water heater, I could use my PLCs, I could use my CMT SVR, anything that supports Sparkplug B, and I can group them together logically at the broker, okay? The reason we use Sparkplug B is because it was designed for industry. It is designed for all the things that we care about with industrial data, okay? Compression's a big component of it, okay? Compression, buffering. So one of the things that we do with the Sparkplug B connection is we say, how often should we send our updates, publish our updates to the broker? So what'll happen is, let's say I set that at 1 second and sensor 1's value changes 5 times in 1 second. The only one that gets shipped is the last one, okay? We publish the last value that happened in that 1 second, okay? So there are a bunch of elements of the Sparkplug B spec that allow us to optimize the transmission of industrial data, okay? But why does Sparkplug B matter? Okay, what's the reason that it actually matters? The reason it matters is that it's far more efficient to use Sparkplug B for industrial applications because I can build my namespace here. I can build out a local namespace for this node, okay? Hierarchy and a semantical namespace, okay? One that makes sense. And then I can package it all up as one node and publish everything for that node up. Establish a connection, now publish my logical namespace, and then keep sending my updates. As opposed to with MQTT 3.1.1, there are elements I'm missing, okay? Number one. But number two, I'm sending each topic individually. So if I've got 10,000 topics, okay, I don't want to have to do 10,000 publishes from my MQTT client. I may not want to do that. It may make more sense for me to package everything up nice and neat in an edge of network node and publish it to a specific space in our unified namespace. Couple important things here. Number one, my MQTT broker doesn't care whether my payloads are Sparkplug B or not, okay? So I could have a broker that can't decipher, that is, it can't unpack a Sparkplug B payload. But that doesn't mean that it can't administer it for a client that can, okay? So as long as my broker is built on the MQTT 3.1.1 specification, I can connect a Sparkplug B client to an MQTT 3.1.1 broker, and a Sparkplug B client out here will be able to subscribe and decipher the payload, okay? That's number one. Number two, because of that, I can put MQTT 3.1.1, MQTT 5, and Sparkplug B payloads all together, okay? Where do I want to do this? So what's the application for Sparkplug B? Where do we do it, okay? One of the things that you'll remember when we talk about the rules for digital transformation, we treat all the smart things in our business as nodes in an ecosystem, okay? Nodes is in an ecosystem. So what we will do is we will group industrial data by logical nodes in the organization. A really good example would be a production line. So I may have a production line that has multiple PLCs, okay, and I may have an instance of Ignition Edge running out there, or an instance of TATSOFT's Factory Studio, or I may have an instance of Flow software, or I may have a Canary Labs Historian, I may have not Kepware because they don't support Sparkplug B yet, right? I may have an IO Hub running out there, I may have a PLC Next running out there, I may have an Opto 22 Groove Epic running out there. And what I would do is logically group the data, all the instrumentation data and any of the other data that I'm collecting in that node. And then I would use Sparkplug B to package that edge of network node device all nice and neat for publishing to the broker. Or I could do it manually. I could do the same thing, except I'm not creating an edge of network logical grouping, okay? This gives me a lot more flexibility in how the data is going to be presented in the namespace. I can take value from this sensor and I can put it over in this location in the namespace. I can take value from that sensor and put it in that location in the namespace. But anything that I send over Sparkplug B is all going to be grouped logically in the group ID that connection is publishing to. And in the device ID. If I don't add an edge node ID, then it's by default, it's going to use the MQTT client ID in that space. Go ahead.
For the edge of network device, does the device ID have to be unique?
This is a one-to-one relationship.
Oh, okay.
Yeah, this is just an extra layer.
Okay.
This is an extra layer. And this is a common question that comes up in Sparkplug B is, hey, when you start building out namespace and you're going, okay, well, where do I want to organize my data from my device out there? Where do I want to organize it? Getting this right is important with Sparkplug B, okay? The most common application for Sparkplug B for us, though, is basically two places. Number one, when we're logically grouping by a production line or an area or a PLC, and we say, you know what, that's an edge of network device, and we want everything that I'm collecting to go to the same place in the namespace. So let's go ahead and get all the advantages of Sparkplug B. Let's get compression, okay? Let's leverage store and forward, right? All those things, the protocol buffers. Let's leverage that stuff to optimize that transmission even further, okay? But number two is this sensor is in the OPC UA world would be like an information model from a companion spec. The way that this is organized is a data type. And I want the clients out here to know that I'm consuming a data type. The only way for us to do that seamlessly is by using Sparkplug B and the mechanisms in the specification to say, hey, this thing in the topic namespace is a template. It is a user-defined data type. It is a model. It's a data model, okay? All right. So that's Sparkplug B in a nutshell, okay? Sparkplug B, a quick run through again. It is a standard managed by the Eclipse Foundation telling you how to create logical edge of network nodes in your MQTT ecosystem that are optimized for publishing industrial data. When you are building unified namespaces, when you are building topic namespaces, your topic namespace is almost always a combination of purely flat MQTT 3.1.1 topics and Sparkplug B topics living alongside one another in the same namespace. And then we generally use our clients to manipulate this even further and normalize and unify, okay? So I may take this value here and a value from this and put them together in a new logical area in the topic namespace, okay? Number two, Sparkplug B introduces the concept of a group ID, an edge node ID, and a device ID, and those things are part of our logical grouping for our sensor data and our Sparkplug B client. Number three, we introduce support for store and forward using the Sparkplug B specification. If I lose my connection, I can buffer the data locally, and then I can transmit once I reconnect. We add in support for flagging topics as user-defined data types. There are also other mechanisms in here. There's a whole host of other things in Sparkplug B I'm not highlighting here because there's no way for me to do it without basically boring the shit out of everybody. We add in support for compression, additional support for compression, and we remember, most important, what is Sparkplug B for? It's really for creating edge of network devices in our topic namespace, okay? So for every Sparkplug B connection that you have in your ecosystem, you have an edge of network device, a logical edge of network device that groups everything together, okay? That's it.
And it could run on the IO Hub.
Yes, and it could run on the IO Hub. All right, good.